Somewhere inside a government office in the United States, a woman goes to sleep every night thinking about something that does not exist. Not a conspiracy, not a rumor. A physical object tumbling through space right now that no telescope on Earth has ever seen. She does not know its size. She does not know its speed. She does not know if it is heading toward a stretch of open ocean or a city of 10 million people. And her job, her actual official job title inside NASA, is to find it before it finds us. Read that again? This is not science fiction. This is the acting head of NASA's Planetary Defense Coordination Office, speaking on record, in public, to a room full of scientists. And what she said next is the reason this story exists. Her name is Dr. Kelly Fast, and in February of 2026, standing in front of the American Association for the Advancement of Science in Phoenix, she said the quiet part out loud. She warned that Earth currently has no reliable way to stop thousands of so-called city-killing asteroids that could one day strike the planet. Not one asteroid, thousands. And the terrifying part isn't even the ones we know about. The greatest threat, according to Fast, comes from the asteroids that haven't been detected yet. In her own words, delivered without theatrics, without exaggeration, simply as a working scientist stating a working problem, what keeps me up at night is the asteroids we don't know about. Sit with that for a second. This is not a fringe theory from a late-night forum. This is the acting planetary defense chief of the most advanced space agency on Earth, admitting, in a professional setting, that the sky above us is still mostly a blind spot. But here's where it gets more complicated. Because it would be one thing if the danger were simply, we haven't looked hard enough. It's worse than that. Fast explained that scientists are not primarily worried about the biggest asteroids, the ones that could end civilization, because those are well tracked. They're also not worried about the tiny ones that burn up harmlessly in the atmosphere every single day. The danger sits in the middle, a size range large enough to level a city, small enough to vanish against the darkness of space, and this is the part that should unsettle you, a size range where less than half of these objects have ever been cataloged. That gap in our knowledge is not a rounding error. It is the entire ballgame. To understand why that gap exists, you need to understand what these objects actually look like from the perspective of a telescope on Earth. Most asteroids in this dangerous middle range are not shiny. They do not reflect sunlight in a way that makes them easy to photograph. Many of them are covered in dark, carbon-rich material, essentially charcoal black rock drifting through the void, absorbing light instead of bouncing it back at us. A ground-based optical telescope, the kind humanity has relied on for decades, is looking for something bright against a black background. But what if the object itself is also black? What if it's approaching from the one direction no telescope on Earth can safely stare into, directly from the glare of the sun? This is not a hypothetical weakness. This is a known, documented blind spot in planetary defense, and it has already produced a real scare. That scare had a name, 2024 YR4. And this is where the story stops being theoretical and starts being something that actually happened in front of the entire world less than 2 years ago. The asteroid was first spotted on December 27, 2024, by the Atlas Telescope System in Chile. At first, it was just another entry in a long list of cataloged space rocks. Nobody outside the planetary defense community even noticed. But then the orbital calculations started coming back, and the numbers did something they were never supposed to do. They kept climbing. Think about what that actually means for the scientists running those calculations. This isn't a movie script where the countdown clock is fake. According to the European Space Agency, 2024 YR4 went on to record the highest impact probability ever calculated for an asteroid of its size, over 30 meters wide, surpassing even the infamous asteroid Apophis, which briefly spiked to a 2.7% chance of impact back in 2004. Let that sink in for a moment. This wasn't some ancient, long-monitored object. This was a rock discovered days earlier, already climbing toward record-breaking odds of hitting Earth. And it did not stop at one number. Between its discovery and mid-February 2025, the estimated chance of impact rose from 1.2% to 2.3% to 2.6%, and finally peaked at 3.1% on February 18, 2025. Every single one of those percentage increases represents another round of telescopes locking onto this object, another team of scientists rerunning the math, another moment where the acceptable range of definitely safe got a little bit smaller. For roughly 6 weeks, a real, tracked, non-fictional asteroid carried odds of hitting Earth that would make any airline refuse to let you board a plane with a similar failure rate on its engines. But here's the twist nobody saw coming, and it's the twist that should actually worry you more than the danger itself. Just one day after that peak, everything reversed. The risk fell to 1.5% on February 19th, then dropped dramatically to 0.28% on February 20th, and within days after that, plummeted to a probability of just 0.050%. The asteroid didn't change course. It didn't get smaller. What changed was the amount of data available to astronomers. In under a week, humanity went from treating this object as a plausible generational threat to almost entirely dismissing it, not because the danger had been neutralized, but because we simply hadn't been watching it long enough to know better in the first place. This is not chaos. This is the system working exactly as it's supposed to. But think about what that reveals about every other object we haven't found yet. If a real, tracked, publicly monitored asteroid could swing from 1 in 300 all the way up toward 1 in 30 within a matter of weeks, purely based on how much observation time we'd had, what does that tell you about the objects currently sitting in that same size range, unlisted, unwatched, with zero observation history at all? The uncomfortable truth is this: 2024 YR4 wasn't dangerous because it was unusual. It was dangerous because it briefly showed us in real time exactly how thin our safety margin actually is. And the story of 2024 YR4 wasn't even finished there, because once Earth was cleared, a new target appeared, and this time it wasn't our planet at stake, it was the Moon. New infrared observations from NASA's James Webb Space Telescope refined the asteroid's estimated size to somewhere between 174 and 220 feet, roughly the size of a 10-story building, and increased the probability of a lunar impact on December 22, 2032, from 1.7% to 3.8%. A collision with the Moon wouldn't threaten life on Earth directly, but picture it anyway. A 10-story building of solid rock slamming into our nearest neighbor in space, visible from your own backyard. A live demonstration of exactly what these objects are capable of doing to a solid surface. And this is where everything changes, because that scenario forces a question nobody wants to answer out loud. If we can watch an impact happen on the Moon and still only manage a coin flip level of certainty about it, what happens when the target is us? This is precisely why the DART mission exists, and why it matters more today than it did the day it launched. Most people remember DART as a headline. NASA crashed a spacecraft into an asteroid on purpose. What most people are not seeing is what that mission actually proved, and more importantly, what it did not prove. In 2022, NASA's double asteroid redirection test successfully altered the orbit of a small moonlet called Dimorphos, deliberately slamming a spacecraft into it at roughly 14,000 miles per hour, and in doing so, demonstrated that asteroid deflection through kinetic impact is genuinely possible. For the first time in human history, our species proved it could reach out across millions of miles of empty space and physically alter the path of another celestial body. That is not a small achievement. That is arguably one of the most significant technological milestones humanity has ever crossed. But, and this is the part that gets buried underneath the celebration, the same mission that proved this technology works also quietly revealed how limited it actually is. Nancy Chabot, the DART mission's own lead scientist at Johns Hopkins University, has cautioned that simply replicating that same strategy against a future threat is far from guaranteed to work the same way twice. The real story is this: Dimorphos was a small, well-understood target in a stable binary system, deflected years in advance under laboratory-like conditions with no real-world time pressure. A genuine planetary threat would almost certainly not offer humanity the same luxury. Different size, different composition, different amount of warning time. And here's the sentence that should replay in your head for the rest of this. Proving a hammer can hit one specific nail does not mean you have a hammer for every nail in existence. So if deflection is possible but not guaranteed, what does that leave us with? It leaves us with detection. And this is where the real power shift in this story begins. Because right now, the single most important piece of hardware standing between humanity and a repeat of the 2024 YR4 scare, except without the lucky ending, does not even exist in orbit yet. It's called the Neo Surveyor, and it is, without exaggeration, the closest thing humanity has to an early warning system for the entire planet. The mission is a dedicated space-based infrared telescope designed specifically to hunt down city-killer asteroids, defined as objects at least 140 meters, or 460 feet, across, and of which only around 45% have ever been discovered. Read that number again. Less than half of an entire category of objects capable of leveling a city. These asteroids evade ground-based detection precisely because they are too dark to reflect visible light, or because they approach from the direction of the sun where no conventional telescope can safely look. This is the exact blind spot that let 2024 YR4 sneak up on us with barely 2 years of warning. Neo Surveyor exists specifically to close that gap, using thermal sensors instead of visible light, hunting for heat signatures instead of reflected sunlight, detecting the objects that have been hiding from us in plain, dark sight. Its position will be extraordinary, Parked 1.5 million kilometers from Earth at the L1 Lagrange point, a gravitational balance point in space where the telescope can maintain a stable, unobstructed view of the region around our planet. This isn't just another satellite. This is meant to function as humanity's peripheral vision, watching the exact blind spots where every previous surprise asteroid has come from. And here's where the tension tightens, because a project this important should already be operational. It isn't. Neo Surveyor was originally targeted to launch in 2026. Then the schedule moved. By 2026, NASA's own program updates confirmed the launch would happen no earlier than September 2027. NASA has since selected SpaceX to provide launch services for the mission, using a Falcon 9 rocket lifting off from Florida at a total cost to the agency of approximately $100 million for the launch alone. That is real hardware, a real contract, a real target date. But it is also, undeniably, a countdown that keeps sliding to the right, while the objects it's designed to find continue drifting through space, completely unaware that humanity is even trying to catch up to them. Think about the timeline for a moment, because this is where the stakes stop being abstract. Once launched, Neo Surveyor is expected to run a 5-year survey aiming to catalog at least 2/3 of the previously unknown near-Earth objects larger than 140 meters. 2/3. Not all of them. And that's the best case outcome, assuming the telescope launches on schedule, assuming it performs exactly as engineered, assuming nothing goes wrong during a mission that has to operate a delicate infrared instrument in the punishing thermal environment of deep space. Every year this launch slips is a year where the remaining 55% of City killer-class asteroids simply continue moving through their orbits, unlisted, unwatched, invisible to us, in the exact same way 2024 YR4 was invisible until the month it was finally caught. And this is where the deeper, uncomfortable truth of this entire story finally surfaces. We are not actually protected right now. We are protected by an assumption. The assumption that nothing large enough to matter will show up in the gap between the telescope that isn't launched yet and the deflection technology that's only been tested once on one very specific, very cooperative target. That is not a safety net. That is a hope, dressed up in the language of a space program. Now bring the timeline forward, because the future isn't waiting for Neo Surveyor to catch up. In April of 2029, an asteroid named Apophis, a rock roughly 100 feet wide, large enough to be catastrophic on a regional or even continental scale, will pass closer to Earth than many of our own communication satellites. It is expected to miss Earth by roughly 19,000 miles, a distance that sounds enormous until you understand this is astronomically close for an object of that size. NASA has already ruled out impact risk for that specific pass, and later analysis has cleared even the more distant future scenarios that once worried scientists. But that isn't really the point. The point is what that close approach represents. A full-dress rehearsal occurring in real time for exactly the kind of scenario planetary defense officials lose sleep over. Except this time, we know it's coming. This time, telescopes across the planet will be pointed at it years in advance. This time, there's no scramble, no 6-week scare, no last-minute recalculation of odds. Apophis is the controlled experiment. The next one might not be. And that's the sentence that should actually stay with you after this video ends. Because the story of planetary defense right now is not a story about whether the danger is real. Dr. Kelly Fast has already confirmed that. It is not a story about whether deflection technology works. DART already proved a version of it does. It is a story about timing, about whether the single piece of hardware built to close humanity's biggest blind spot reaches orbit before that blind spot produces something 2024 YR4 never quite managed to be. A real one, with real consequences, and none of the lucky margin that saved us the first time. Here's the part almost nobody talks about, and it deserves its own moment before we close this out. Objects in this dangerous size range, the ones capable of leveling an entire city, are not rare curiosities. They are a documented category of ongoing risk that NASA's own Planetary Defense Coordination Office was specifically created in 2016 to track. This isn't a fringe department bolted onto NASA as an afterthought. It is a dedicated coordination office built because the danger was judged serious enough to warrant one. And even with that office fully staffed, fully funded, and actively running observation campaigns, the acting head of that very office stood in front of her scientific peers in 2026 and admitted the honest limits of what her team can currently see. So where does that leave us, sitting here today in the summer of 2026? It leaves us in a strange, uncomfortable middle ground. We have proof that deflection is technically achievable thanks to DART. We have proof that our detection systems can catch a threat with meaningful lead time thanks to 2024 YR4, even if that same event proved just how volatile the early warning numbers can be. We have a next-generation telescope under active construction, with a real launch contract, a real rocket, and a real target window. And we have the honest, unscripted words of the person whose entire career is built around finding these objects before they find us, telling a room full of scientists exactly what still keeps her awake at night. None of this is meant to make you panic. That is not the goal here, and frankly, panic has never once deflected an asteroid. But it is meant to make you look up differently the next time you're standing under a clear night sky. Somewhere up there, among the stars you can actually see, there are objects you cannot. Objects dark enough to swallow sunlight instead of reflecting it, objects large enough to end a city, small enough to have never once appeared on any list, any radar, and any telescope feed anywhere on Earth. We built a mission to find them. That mission is still years from launching. We built a spacecraft to redirect them, and it worked exactly once, under conditions we may never get to choose again. The question this story leaves behind is not whether an asteroid will eventually threaten Earth again. History, mathematics, and NASA's own tracking data all agree that it eventually will. The real question is simpler and far more uncomfortable. Will the telescope built to warn us arrive in time? Or will the next 2024 YR4 be the one where the numbers keep climbing and nobody catches it in time to watch them fall back down?